Good morning, scholars. I hope you're all doing well. We're going to add a couple more notes for our trig section 9.1. Hopefully by now you've been able to draw a few of those special right triangles and solve for the trigonometric identities. Just as a reminder, okay, we're going to start off with, let's say I want to find sine of 57 degrees. On your scientific calculator or even on your phone, you just put in 57 and press the sine button. That ratio will give you approximately 0.8387. The second one you would do is the cosine of 57 degrees, and that's going to approximately be, remember, it's the adjacent side, 0.446, and then of course your last one for tangent of 57, that ratio is approximately 1.5399. Remember, it's opposite over adjacent. The other three are the reciprocals. So if you do 1 over sine, that is equal to what we call cosecant. And if you do cosecant of 57 degrees, that's going to be 1 over 0.8387. Okay? That will give you approximately 1.1924. The reciprocal of cosine is what we call secant. So the reciprocal of cosine is what we call secant. So if you do secant of 57, again, that's the reciprocal of 1 over 0.5446, and you should get approximately 1.8361. Doesn't quite fit on my screen. 1. Okay. Last, we have tangent, and so the reciprocal of tangent is cotangent. If you want to do cotangent of 57, it's going to be 1 over 1.5399, and that's going to be approximately 0.6494. That's just a review of our basic trig identities. And remember, this is our quick way to remember the basic three. It's so, ka, to, ah, because this is opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, opposite over adjacent for tangent. So what we're going to do next is we're going to talk about how to actually use these special right triangles in the real world. And there's some terminology or vocabulary you need to know. One of them being an angle of elevation, and the other one being an angle of depression. So the first thing you need to know is it's always according to the horizon. So if you're a little bird and you're flying along, this is a bird, and you're flying along in the sky. Okay, this is your flight path. Then wherever you're looking down toward the earth, okay, this is the earth, what we call the angle you're looking at, if the bird is flying this way, but looking this way, then this theta, whatever the degree is, this is the angle of depression. We call that the angle of depression because we are measuring from the horizon down to where that angle is. That's the angle you're looking at. Now, say you're down here and you are looking up at the bird. Then from the horizon, if you are, it's always from you up is what we're looking at. So in this case, this is theta, and that's what we call the angle of elevation, because you're going up. Again, just remember it's from the horizon up, but you know, if you wanted to say that the angle of elevation was, say, from the top of your head up to the bird, well, then you'd have to add your own height. Okay, you'd have to add your own height. But basically, these modeling problems, you draw a picture that represents what you're looking for. In this case, you would either have a right triangle this way, or if you were looking up and you wanted to find the angle of elevation, you would have a right triangle this way. Okay, but as long as you have a right triangle, the hypotenuse is across from the right triangle, and then the other two distances are the length of the legs. So you can use the Pythagorean theorem to solve for any leg you don't know, and or use your trig functions, sine, cosine, tangent, to figure out what it is. So the next slide we're going to go and actually do one of these problems. Okay, so I have a parasailer is attached to a boat with a rope 80 feet long. The angle of elevation from the boat to the parasailer is 31 degrees. Estimate the parasailer's height above the boat. Let's draw a picture. So I put a boat in the water. I put the parasailer up in the air. I know that the rope is 80 feet long, so I put 80 feet there. And then I'm looking the angle of elevation from the boat to the parasailer. That's talking about this angle here. That's where I can write 31 degrees. Okay, if I want to know the parasailer's height above the boat, that's going to be this way, the height, because it's always a perpendicular height. So you can see that this is a right triangle, and I'm looking for x over here, or height, whatever. So if this is my degree, 31, then we're talking about the opposite side over the hypotenuse side. The opposite over the hypotenuse, and that's going to be sine. So if we're looking for the sine of 31, it's equal to the opposite, which is x, which we don't know, of course, and the hypotenuse is 80. So you have sine of 31 equals x over 80. And this is the sine of 31. You're just going to pop that in your calculator, of course, and you're going to multiply it times 80. In a perfect world, if we round off correctly, we will get approximately 41.2 feet. And that's reasonable. It's about half of the 80-foot line. And so that's how you use it. These problems are called modeling in the real world. And just remember, the angle of elevation is from the horizon up, and the angle of depression is from the horizon down. So just carefully draw your picture first, and then answer the question. That's all we're going to do here.